the last 10% almost of this exam paper was all on this stuff, and we've got a bit of everything going on in here. Express 1 over 3 minus x, 6 minus x in partial fractions. So it starts with this bit. Slightly unkind and a little bit unusual, but more often than not they give you the form of the partial fractions. But with this one we need to have it, well we know that we split up the two fractions. Remember the tricky bit with this, if one of these brackets had been squared, then we would have had to have an extra term in here, wouldn't we? We'd have to have it as plus c over the 1 squared. But that's only if one of them's squared. Now the next move for this is that we multiply both sides by the denominator to get it into a single line. If we multiply this by 3 minus x, 6 minus x, the 3 minus x cancels out, so we end up with a times 6 minus x. And this one, if we multiply by 3 minus x, 6 minus x, the 6 minus x cancels out, so b times 3 minus x. Make sure you get those the right way around. And so take your time to go through that step, being really careful to get to that point. And then this is quite a nice one because we can see the values that we're going to sub in straight away. We're going to sub in values that make the bracket 0. So we're going to start with x being 3. Sub it into both sides of the equation. The 1 won't change, but we'll get a times 6 minus 3 plus b times 0. So I think that gives us 1 is 3a. So a is a third. And the other value that works is 6, so we're going to sub 6 in, x equals 6. 1 equals a times 0 plus b times 3 minus 6. So we get b as being minus a third. And I'm not sure exactly what the mark scheme said, but I would not want you to leave it like that, because it did say express it in partial fractions. So I think we actually have to finish this off. 1 over 3 minus x, 6 minus x is, well, a was a third, so that's 1 over 3 lots of 3 minus x minus 1 over 3 lots of 6 minus x. And we've put the third into the fraction and tidied it up a little bit. Okay. That was just 2 marks. Part 2. In a chemical reaction, the amount x grams of a substance in time t seconds is related to the rate at which x is changing by this equation, where k is a constant. When t is 0, x equals 0. When t is 1, x equals 1. Show that k is a third and then 5 over 4. Alright, so let's work our way through this. So dx by dt is what we got, k times 3 minus x, 6 minus x. Remember what we just said, in order to solve the differential equation, we need to have anything involving x on the side where x is on the top, and anything not involving x on the other side. To get there, we can't add or subtract things, we can only multiply or divide things. We've got to be clear about that. So we're going to divide everything by this lot that's multiplying k. We could bring the k down if we wanted, but I don't think we will. So 1 over 3 minus x, 6 minus x, dx by dt equals k. Now we're ready to integrate both sides, and we're integrating both sides with respect to t, because that's the thing that's on the bottom there. You don't have to go through the step of what happens with this, but it gives us that as our next line. Now what really happened here is kind of, in doing that, 2 things happened at once. we've got to be clear that we've done the same thing to both sides of the equation, haven't we? Because you've got to do the same thing to both sides, otherwise you change the balance of the equation. So we integrated both sides with respect to t. So really, remember that was dx by dt there, and we put an integral in dt either side of it. And we did the same, an integral dt either side of the k over there. Can you see how that worked out? Because the dt bit cancelled out, and it left us with just dx as we wanted. Okay. Right. So we now need to integrate this stuff. This, we know, is a partial fractions question. And in the same kind of hence way as we did with the last question, we've already done the partial fractions. So this is the integral of 1 over 3 minus x minus 1 over 3 times 6 minus x dx is the integral of k dt. I could have integrated that at that point. I'll do it in a second. Right, let's be careful about integrating this though. If we integrate these things here, that 3, don't get put off by it. If that 3 wasn't there, then it would be the integral of 1 over 3 minus x, and we could do that. That would be the natural log of 3 minus x. I'm going to put modular signs in there, I nearly forgot. I have modular signs in there. Now that minus sign as the coefficient of x means we divide by minus 1. And there was a third there, we can't completely ignore it. So it's a third of that answer, so it's minus a third of what we get from that. Are we happy with that? The next one, same thing is going on here, isn't there? We've taken this away, but we've got a third of 1 over 6 minus x. If you integrate 1 over 6 minus x, you get the natural log of the modulus of 6 minus x. But you have to divide by the minus 1, that was the coefficient of x, but there was already a minus there. So I'm going to call that plus a third, and then 6 minus x. Over here, we are integrating k with respect to t, which gives us kt, whoever she is. Right, and we've finished integrating. Now I know we've integrated on both sides, but there's no need to put 2 constants of integration. We can combine it all together into a super constant, which we'll call c. I'm going to stick it over on that side, so it keeps it out of the way. There we go. Right. What about this then? We were told that when t was 0, x was 0, and when t was 1, x was 1. So let's start seeing if we can work out what some of these constants are. If t equals 0, x equals 0. Let's sub some of that stuff in then. If that gives us minus a third natural log of 3 plus a third times the natural log of 6 is equal to 0 times k, which is okay, plus c. Right, trying. Now, hang on, what do we get here? We've got ln, the third we can take out as a factor, it's ln 6 minus ln 3. Remember your logarithm laws from last year? If you do ln 6, take away ln 3, you divide, don't you? So that's a third ln 2 is equal to the constant of integration. That's good to know. Right, we also had, if t is 1, x is 1. So we've also got minus a third times the natural log of 2 plus a third the natural log of 5 is equal to k times t, so that's now just k times 1 plus a third ln 2. We've got lots of things to tidy up here, haven't we? So let's lump all these natural logarithms together before we do anything with them. We've got a third ln 5. In fact, can I take the third out as a factor? Is that okay? We've got a third ln 5 minus ln, a third ln2 minus another ln2 is equal to k. Have I done too much at once? Is that alright, what we've done there? Taken a third out as a factor and pulled that ln2 to the other side. So that's 5 divided by 2 and another 2. So that bracket is 5 over 4, isn't it? 1/3 ln 5 over 4 equals k. And that was what we were supposed to show, was it not? Show that k is a third ln 5 over 4. There we go. So we've done it. Notice that without kind of mentioning it, we did have to find c along the way there, didn't we? We couldn't have found k without having found c first, because it was involved in that expression. Right. Find the value of x when t equals 2. That was 7 marks we just did there. That's great. Find the value of x when t is 2. So we've now established that our answer to this is minus a third ln 3 minus x plus a third ln 6 minus x is k times t, so t times a third ln 5 over 4 plus c plus a third ln2. That's the whole not particularly nice looking expression, and we have been asked to find the value of x when t is 2. So if t is 2 in all of that, can I start combining it as straight away? Because look, we've got minus a third ln 3 minus x plus a third ln 6 minus x. That's that one, take away that one. So we would divide, wouldn't we? So we're going to say a third natural log of 6 minus x over 3 minus x. T is 2. So this is 2/3 natural log of 5 over 4 plus a third natural log of 2. And here we are ending core 4 with just a big kind of classic end of the exam paper core 2 kind of thing, isn't it? All this manipulating logs and putting that all together is core 2 stuff, really. It would be nice if we could combine this into a single term. The problem is we've got 2 there and a 1 in front of that one, 2/3 and a 1/3. But we can resolve that by squaring the 5 and the 4, can't we? Because that 2, is that alright to think of it like that? And pull it all together as a single thing? So this is...
Multiply everything by 3 first.
Well, alright, I will do. We don't have to. We'll multiply everything by 3 then. If you want. There we go, so we get that. Before we can combine this, it needs to be the same coefficient in front of both things. So that 2 needs to be up as a power, squaring all of that. So that is ln 25 over 16 plus ln2. That, I said 25, but the board misheard me, wrote 26. Which, combined together, means that the natural log of 6 minus x over 3 minus x equals the natural log of 50 over 16. And why I didn't write it is 25 over 8. I don't really know. I've not been moving up because the board has decided I've done too much maths on this page and won't let me extend the page any further. So at this point, we've got natural log of something equals natural log of something. So the somethings must be the same. Let's ignore the natural logs and say 6 minus x over 3 minus x is 25 over 8. Was it 25 over 8? Yeah. Good. And let's solve this linear equation by multiplying everything by 8 and 3 minus x to get 8 times 6 minus x is 25 times 3 minus x. We're nearly there, aren't we? 8 sixes. Minus 8x is 75 minus 25x. So some numbery things happen and we end up with 17x is 75 take 48. Sorry?
27.
Oh, good, thanks. So we end up with the uncomfortably unpleasant answer of 27 over 17, which was the right answer. It's not very satisfying, is it, to get to the end of a core 4 paper and then have 27 over 17 as the final defining moment of your 2 years of core maths. But there you are, that was it. And that's maths.